This is section 3.1, and we are going to look at graphing inequalities. And here's the steps that you want to think about when you're working on one of these problems. First, you want to change the inequality to an equation. And you're going to graph that boundary line that you get when you do that. It will be a dotted line if it has a less than or greater than. It will be a solid line if it has the equals under either of those. Then once you have that line drawn, you're going to choose a test point and plug it into the original inequality, and you will shade where it's true. So those are the steps. Now let's look at the problems I think we'll learn by doing. All right. So number 1 says graph the inequality on a plane. All right, so you might be given x plus y is less than or equal to 6. So remember our step 1 was to change it into an equation. So we have x plus y equals 6. It's always easier to graph if we have it in the y equals form. So we'll subtract the x over. So we have y equals negative x plus 6. Well, we know that when we graph that type of line, we start with the y-intercept. So I put a dot at 6, and then this is my slope. So your slope is negative 1, which means down 1 to the right 1, down 1 to the right 1. I've got 3 dots. I connect those dots, and I use a solid line because over here in my original, I had less than or equal to. So now I have that. I want to test a point on either side. Well, it makes sense to test 0, 0 because that's easy to plug in. The only time you wouldn't use that is if the line went through 0, 0. So when I put 0 for x and 0 for y, I get 0 plus 0 is less than or equal to 6. Well, is 0 less than 6? Yes. So we'll shade where that point is. So we shade all of this. Now when you're doing this on the calculator, first of all I would suggest clicking to enlarge your graph. Then you want to choose your tools down here. So for the line, you have to either decide if it's solid or dotted here before you do your line. So in our case we would have chosen that solid line, and then you can click on the 6, and then holding your cursor down you'll move and you'll come over here and it will draw the line. Once you've got your line drawn, you do this work to decide where you're going to shade. And when you're ready to shade, you will choose this tool, the bucket of paint tool right here, and click on the area that you want it to fill, and it will fill with the right color, and you can go from there. So that's how we'll do those. Number 2 would be the same way. Now, let's see, let's get to this one. Number 3 says graph this one that says x is greater than y. So when I come over here, I've got x equals y. And maybe turn it around if it looks better for you and write y equals x. That's a y-intercept of 0, so I put a dot at 0, a slope of 1, because there's no number in front of x, so that's an understood 1. So up 1 over 1, up 1 over 1. I know it's dotted because I do not have the equals under there, so I would choose the dotted line there, click my line tool, and do my line on my computer one. Then to test, I can't use 0, 0. This is that example where it goes right through 0, 0. So I chose a point over here at 4, 0. So let me put a dot there. So I'm going to plug in, and I have 4 for x and 0 for y. Is 4 greater than 0? Yes, so that's true. So this is where I would click on my paint icon and click here, and it would put yellow right here. All right. X is greater than or equal to negative 1. We know that x equals negative 1 is a vertical line. It's going to be a solid line because it has the equals under there. So choose your solid line and at x equals -1, you can click on one point, go to another point right up there, it'll draw your line. And you kind of know, you can test 0, 0. It is true. 0 is greater than -1, so you're going to shade here. Now we get to a system of equations, and you won't be having all of this shading in your final answer on the computer, but what I would suggest you do is do this on paper and get it all done, and because you're only going to fill on the computer the final answer, the overlap that you see here. So you take each equation and rewrite it, and I put colors here. Those are not negative signs. That is, purple is that line and black is that line. It's not real clear. Well, let me do that. Well, that didn't help. That didn't help a bit. Okay, so let me make that a little bit thicker. Okay, so that's a purple line, and this is the black line. All right, so we had x plus 3y is equal to 9. We subtract the x, and then we divide by 3. So we've got y equals -1/3 x plus 3. So if I'm going to do that one over here, I've got a dot at 3, and then down 1 over 3. Down 1 over 3. There's that line. Okay? Same thing with this one, 3x plus 4y equals 12. -3x, and then divide by 4. So you've got -3/4 x plus 3. I have the dot at 3 as well, and I'm going to go down 3, 1, 2, 3, and over 4. So now I've got that line coming in there. Okay, so that should have gone through that little red dot there. That isn't real accurate. Okay, and so then you want to do your same thing. You test 0, 0 in both of them, and for this line, shading was true down here. For this line, it was false when you plugged in 0, 0, so you shade the other side of the line. So that was the blue. The overlap, this green, would be the answer. Okay, the green would be the answer. So when you went to, you would draw your lines on here. You would have figured out on paper that it's only this part. You would click your bucket and click only in here. So you're not going to have shading here, and it's going to show an overlap. You only want to shade right in there for the final answer. Okay? And it's unbounded because it's going on and on forever this way. All right, and you would do the same thing with number 6 and number 7. Do them on paper and try to match, see which one matches, but you're going to follow that same procedure. All right. Now this one says use a graphing calculator to graph the following. So I did the same thing, and I did do it with a graphing calculator, and let me show you the screen. Let's see. This one, when you go in to put them in there, let's see if we can get that up. It's not on, so we'll get it up here. Okay, so I've brought this calculator. Now this may not look like your screen. This is like the newest one, but I can show you in the other format as well. But I turned each equation into y on one side and everything else over here. So this is y is greater than 1/2 x minus 3. So I've got 0.5x minus 3. And -6/7 x plus 6. So I've got that. Over here, in this particular one, if we hit enter there, we can change the color of the line, and we can change the line itself. So this says greater than. If I went to the other direction, I don't know if I can't get that. not changing for me. Alright, that's not good. Oh, I'm using the keys. Okay, so it can be greater than. If I went that way, it's just the line. So we definitely want it to be greater than, and then we come down to OK and hit OK there, and that one's already changed as well. And so when we graph, that's how I got this particular graph here, because that one's greater above that line, and then you come in with the other one and it is greater up here, and you can see the overlap is right up here. And so let's see, that is that one right there. Alright, now if you had the other kind of calculator, let's see if I can get that in that one. Okay, so let's go to y equals, and you have a different thing here, but what you can do is come over here, and if you hit enter, it changes the different lines, and so there's greater than. So it looks a little different. You certainly don't have colored lines, but it would accomplish the same thing. So I like the newer one, but I wanted you to see that. Alright, so that's how you would do that one. Then you have a word problem, and again, this is a calculator issue. This is talking about a company producing shawls and afghans, and you fill in they've got a little chart for you. So it says a shawl requires 1 hour of spinning, 1 of dyeing, and 1 of weaving. An afghan, 1, 2, 4. There are at most 7 hours available each day for spinning, 8 for dyeing, and 12 for weaving. So I've got my equations, and if I let, let's see, x plus y has to be less than or equal to 7, x plus 2y less than or equal to 8, and x plus 4y less than or equal to 12. And when you change those into y equals, you get these equations. So again, I put them in my calculator here, and I did that, and I did less than, less than, less than. I got my picture, which shows my, and I did make y is greater than or equal to 0 and x is greater than or equal to 0. That's because you couldn't have negatives in those. So I've kind of got, this picture doesn't show just this quadrant, but I am showing just that. Like this would be what it was. Does that make sense? I hope. But I changed the windows so that it would look like that. And when you do that, you can choose the correct graph there, and then you can answer the questions. So hopefully that will work for you in solving these inequalities by graphing.